Cool. So as Joe said, I'm founder at Conflux, and I'm a co-author of the book Team Topologies. You can find me on social media there. Scan the QR code if you like, or if you just search for Matthew Skelton, all one word, you'll find me on LinkedIn and Mastodon. So this is the book that I co-authored with Manuel Paish back in September 2019 is when it was published. So that's 4 years and like 2 or 3 weeks, I think, since the book was published. So there's been quite a period of time where organizations have had a chance to adopt it and use the ideas and techniques and so on. The book's published by IT Revolution Press, the home of DevOps Handbook, Accelerate, Phoenix Project, all of these amazing books, coordinated by Gene Kim. And he's got an amazing team of editors and other people involved. Pretty much any book from IT Revolution is worth buying and reading. So the Team Topologies book has won a few awards, including things like Best Product Management Books of all time. It's actually quite difficult to categorize the book because it touches on product management, teams, organization, technology, architecture, a whole bunch of things like this. It's right in the middle there, kind of coordinating and having to think about all of those things in the context of fast flow. So this is how we describe the approach. Team Topologies is the leading approach to organizing business and technology teams for fast flow, providing a practical step-by-step adaptive model for organization design and team interaction. And it's the team interaction part that actually provides us some really useful signals, as we'll see throughout the talk today. Some of the things that this approach, Team Topologies, encourages and strongly suggests are things like this. We need to continuously untangle business concepts, because too often at a business concept level, we've got multiple different concepts kind of brought together unnecessarily. What we're trying to do is untangle these. So it's easier to have separate streams of value, separate value streams effectively. But historically, many organizations did not take the time to really think about the nature of that business challenge or problem or domain, let's say. And so if they didn't untangle it, then the software is also going to be tangled. And so if we want to go faster, we actually have to spend time kind of right up here at the conceptual level, really understanding the nature of the business and separating out things which don't need to be kept together. And so more fundamentally, there's activity in this space that's needed to find and adjust team and system boundaries for flow. You can adjust boundaries in lots of different ways, but we're thinking about it from the perspective of flow. How can we get things, multiple flows of change through the organization? And this is a new kind of skill and technique that's really needed. Clearly, we need to minimize handoffs from one team to another, because in the context of flow, a handoff is effectively something that really blocks flow, in the sense that we've got two different queues, and if we're waiting, that creates a huge delay to flow. So we try and look for opportunities to minimize or even remove entirely handoffs from one team to another. Likewise, we try to avoid blocking dependencies. So let's say historically you might have had a security team or compliance team or some other kind of team that is going to check the changes that are coming down towards production. And they're doing that for a good reason, because it's like checking for compliance or checking for kind of security challenges or whatever. But the problem is, if you're waiting on another team to do that stuff, that is blocking flow. So how do we get the same capabilities out without having a blocking wait on another team? This kind of fast flow Team Topologies approach also implies we need to move some decision making to teams. So we're empowering the teams to make certain kind of decisions. Well, what's really interesting from my perspective now, 4 years on since the book was published, is that Team Topologies actually exposes any lack of clarity in purpose, conflict in priorities, or misalignment of incentives. And those things there are all things which we need to address to make businesses more effective, organizations more effective in general. Like, Team Topologies doesn't necessarily provide the solutions, but it's exposing any problem, any gaps there. And then we can take the time to address them using a combination of techniques. Okay, so this is what the talk will look like today. We'll look first at the cost of tangled software. Then we'll look at the use of the DORA Metrics and Team Topologies to help address that. Look at some real world examples of detangling. And finally, then some practical ways of like how to detangle with metrics and Team Topologies. And the summary of the talk is this: flow. If you want a one-slide summary, it's all about flow. Flow is it's kind of ancient in some respects, but it's actually relatively new in terms of a guiding principle for thinking about organizations, for thinking about architecture, for thinking about teams, and a bunch of these things. So some of the implications that come out of working in this way actually seem quite strange to many people. The slightly longer version of the summary of this talk, if you fancy you need to go to sleep or go and get some food or something, is this slide here. So use balanced health. So you need to use balanced health metrics like the DORA metrics, flow, cost, blockers, and so on, plus some team topologies techniques like team interaction modeling, independent service heuristics, and user needs mapping to help find good boundaries for fast flow by untangling, that's decoupling, separate services. That is the one slide summary, really, of what we'll be looking at today. Let's have a look at the cost of tangled software then. Here we go. Thought experiment. Excuse me. If each engineer in the organization is blocked for 1 hour per working day, how much does this cost? When I say blocked, I mean, let's say we're waiting on another team to do something before we can progress with our work. I'm not saying we're waiting on our team members. Let's say we're working as a team, but over the whole organization, just 1 hour out of 8 hours in the working day. We're waiting for the security team to do something. We're waiting for the infrastructure team to do something else. We're waiting for an API team to finish the updated version of an API so that we can then update our client-side code to call into that new version of the API, whatever. How much does it cost? Well, let's do some calculations. Let's say the fully loaded cost of an engineer is about 160,000 a year. It doesn't really matter exactly, but let's say it's that. Let's say there's 260 paid days in the year and a total of 400 engineers in the organization. If you do the calculations, that's 8 million euros a year. Now that is quite a lot of money in most people's experience. This stuff costs money. Tangled software, tangled delivery approaches costs a significant amount of money. And when I say untangling, I kind of mean decoupling. Decoupling being separating things that do not need to be together. Visually, it looks like this. Here's two railway wagons that are very tightly coupled. What we're trying to do is uncouple things that do not need to be together. Things that need to be together, we keep together. But actually, it turns out, using particular kind of techniques and approaches, there's a lot of stuff that we can actually decouple, particularly in a software context, not just in a software context, but particularly in a software context with modern techniques, cloud, automation, and so on. The decoupling enables shorter time to value. This is also what we're after. Decoupling enables multiple independent flows of change, each with its own cadence. So these things are changing separately. We don't keep them in lockstep, change them all together. Each flow has its own cadence. So it looks a little bit like this. They've got different kind of things happening, multiple different like sizes of flow, smaller flows, larger flows, happening at different times. It's worth pointing out we're trying to decouple teams and technology, but as a social practice, we're mingling ideas for learning. So let me explain that. Decoupling, we're decoupling teams and software and technology and deployments and data and business concepts. We're keeping things apart that don't need to be together. But actually what we're doing is trying to mingle practices, principles, learning, techniques, and approaches. And we do that by things like this, a lunchtime meetup, or a lunchtime talk, or an internal tech conference, or these kind of things like writing articles and blogs and showcasing and a bunch of these things. We're allowing the awareness and learning to diffuse across the organization, across these team boundaries, but we're being very clear to keep the stuff itself, the services, the products themselves, along with the architecture and the teams, decoupled. There's actually an interesting side note here around decoupling for reliability. If any of you are working in the kind of SRE or that kind of operation space, then decoupling is actually, if you do it well, it's actually a technique that can reduce the number of failure modes in software, which is one way of helping to improve reliability, right? Decoupling can also help to prevent cascading failure. So like W fails, which then causes X and Y and Z to fail in a kind of chain. I mean, it doesn't guarantee it, but it gives us more options about preventing cascading failure. And decoupling can also help to contain kind of the blast radius when errors occur. So it's a bit like these are kind of bomb containers. Here's one from the FBI in the United States. You put the bomb inside the container, and then it can explode inside there, but the explosion's contained. So actually decoupling, if we do it in the right way, we're effectively giving ourselves options for increasing reliability. Ultimately, it's basically good engineering is what we're saying. Okay, so tangled software is expensive. We had the 8 million figure for 400 engineers blocked for 1 hour a day, which is kind of modest because in many organizations, engineers are blocked for far more than 1 hour every day. So let's look at how we can use DORA metrics and team topologies to help address this. The starting point can be to use the 4 key metrics from the Accelerate book, DORA Metrics, and add what we might call a blocker count. So here's the book Accelerate, published again by IT Revolution Press, the same publisher as Team Topologies, published in 2018. The lead author is Nicole Forsgren. And this is based on a whole bunch of research that they've been doing over the previous few years. And they came up with 4 key metrics that really underpin a lot of high organizational performance. It's not the only things we need to look at, but they're kind of like a nice foundation, a nice starting place. There's lead time. That's depending how you count it, but kind of version control to production if you're working in a software context. Deployment frequency, how often are we deploying? Mean time to restore, how long it takes on average to restore a service in production after it fails. And then the change fail percentage is how often the percentage of changes to production that fail. And what's interesting here is we're balancing fast flow, so that's lead time and deployment frequency are principally about getting stuff flowing. We're balancing that with actually encouraging operability, making this stuff work well. So mean time to restore and change fail percentage. So it's a nice balanced set of metrics. And these are strongly indicative. Like if you're improving in this area, it's strongly indicative of higher organizational performance, which is great. There's something else that's worth looking at as well, which is flow efficiency. What percentage of the lead time is actually real work? Because it turns out in lots of organizations, even so, you might have let's say a reasonable lead time. Maybe it's like a couple of days or a day or something, or even maybe you think reasonable is like a couple of hours. But actually, if the proportion of time that you spent during that lead time doing actual work is really small, then there's still lots of waste in there. And it turns out in lots of organizations, the flow efficiency is very low. It's like down at 16%. So only 16% of that lead time is used doing useful value add work, which is, well, it's financially inefficient at that point. So we can, in theory, measure the wait time between these different value add activities. Here's like a value stream map or a version of a value stream map. In theory, you can measure the waiting time between these value add activities. In practice, it becomes pretty hard. So measuring the waiting time is actually quite hard. So what you can actually do as a proxy, as a reasonable fidelity proxy, is just count the number of times that you wait during that lead time. And that's a reasonable proxy, because if there's only a single point where you wait, then let's say on average, there's less of a problem than if you're waiting 10 times during that lead time, typically speaking. It's much easier to count the number of blocking waits, basically. So we can start with this five set of things. It's the 4 key metrics plus the number of times that we're blocked. The number of times we have to wait on another team during that lead time. Now, here's the thing. We're not just counting these metrics just for the fun of it or for some kind of gamification. I mean, that's fine. But what we're doing is this. Using these 4 key metrics and the block account to assess and find better service and team boundaries for flow. Because if we start to track these metrics and go, hey, if we adjusted the responsibility boundaries between this team and this team, then the first team would actually not wait as much and would be able to own this thing end to end. And the second team would not have as many interruptions and they'd be able to own their stuff better. So with the way in which we're using these 4 key metrics in the block account is to adjust responsibility boundaries, team boundaries, architecture boundaries for flow. We're trying to reduce the number of block accounts in particular. We're asking questions like this: if we adjusted the service and team boundary here, would it improve the 4 key metrics? Let's test it out. Likewise, if we adjusted the service and team boundary here, would it reduce the blocker count? And so on. So it's a way of using these metrics are already known to be useful in terms of flow and high organizational performance, but the way in which we're using them is to provide input into a conversation about adjusting boundaries to improve flow. There are some related techniques that have emerged from the Team Topologies community. The first one is independent service heuristics, ISH. And this is the rules of thumb for identifying candidate value streams and domain boundaries by seeing if they could be run as a separate SaaS or cloud product. You'll find details on the Team Topologies website there in the slides, but the way in which we use them, these heuristics is there's a GitHub page basically with like 10 questions effectively. But the way we use these is to run group learning and discussion sessions where we're crowdsourcing the awareness of possible boundaries from across the attendees. So we've had attendees from like engineering and operations and testing, but also like strategy, product, physical warehouse, even in the case of one retailer in Southeast Asia that we ran it with, the head of the physical warehouse where the clothes were stored before shipping was able to get involved with these other roles and discuss where would effective boundaries be for flow, ownership boundaries. So the technique is very powerful in the sense that it's using group awareness, group intelligence effectively to align awareness, to increase awareness across the group, to align awareness and to surface things which are not obvious across different roles. And it becomes you end up with a kind of a heat map, like you see on the slide here, a heat map of possibilities for, oh, well, it looks like we might be able to split this user journey or this product or service or something. We might be able to split this off as a separate thing and run it separately, and that then allows a team to own that entire thing end to end. But it becomes a really useful kind of group awareness technique that can incrementally find and adjust boundaries on an ongoing basis. There's another technique called user needs mapping, UNM, which is actually based on aspects of Wordy mapping, if you're familiar with that. If you're not, it doesn't matter. But the key thing is we start with the user needs at the top of the diagram, and then we work out the kind of things that support those user needs underneath, and then we overlay some of the Team Topologies principles around different types of teams. In the diagram here, you can see there's two what we call stream-aligned teams, shown in yellow, which is kind of like an end-to-end service team. And then there's also a platform shown in blue towards the bottom, platform grouping. It allows us to explore possible team responsibility boundaries based on specific sets of user needs. And again, it ends up being really, really powerful. Been doing some work with a UK government department recently on this, and this revolutionizes the way that they think about putting together teams to meet citizen needs, basically for their users in that context. Then the third technique is team interaction modeling, TIM, and it describes how to reorganize teams and their interactions to achieve better flow and deliver value faster. It uses these specific Team Topologies diagramming styles that we've come up with. They're quite similar to the styles that are in the printed book, but the printed book used some styles that were difficult to represent in digital tools. So we've tweaked the look and feel of it slightly. And we've got kind of open source, so Creative Commons versions for like Google Slides and Miro and Mural and I can't remember, a whole bunch of Excalidraw and a whole bunch of digital tools that you'll be familiar with. And crucially, it helps to emphasize flow. So these diagrams have a flow of change arrow that shows flow from left to right. And it helps us then think through capabilities. It helps think through how the team relationships might evolve over time as we develop more capability, as we use new technologies, as our cognitive load increases, and a bunch of these kind of things. And again, this kind of technique is really helpful for thinking about how we reshape boundaries for flow. So let's have a look at a few examples now of detangling for fast flow. And the first one comes from JP Morgan, financial powerhouse, and there's an amazing talk from Fast Flow Conference, which was held in London early this year in May. And it's how JP Morgan applied team topologies to improve flow in a market-leading enterprise platform. The video is online. You'll get the link in the slides later. But the key thing is this: at one point during the talk, the speaker talk, there are three speakers, but one of them talking at this point, shows how they went from a very tangled team interdependency setup. That's on the left-hand side. Then they used team topologies to help think through a different way of organizing the teams for flow. And the resulting dependency map is on the right-hand side. And you can see there, they actually reduced 60% of their dependencies through better team design. And the result of that, of course, is that they're getting more value for their money because they're able to get things out sooner. They're not paying people to wait around on other people. Now, we don't know exactly how much money they saved. I don't know whether it was more or less than 8 million, but we can do the calculations similar to the calculations that I did at the beginning, and you can start to see that this kind of stuff is going to save a lot of money every year. Second example is from Wealth Wizards. They offer financial advice, founded quite a while ago, based in the UK. They like to use explainable AI. They were going through a growth period just before 2019, a huge growth, but then in the middle of 2019, things ground to a halt. The architecture and the deployment processes and so on just weren't working, and everything was kind of tightly coupled. Thankfully, a couple of months later, the Team Topologies book was published. We did some early work with them on the independent service heuristics that I mentioned before. There's the GitHub link that I mentioned. And actually, that helped them to think through, again, some options for thinking through a different approach to their architecture. And early 2020, they reworked their architecture using some of the Team Topologies team types and principles in a way which then helped to unblock their deployments and gave them a better approach to kind of independent flows of change and better ownership of different parts of the system. And Richard Marshall, who was the CTO at Wealth Wizards at the time, says Team Topologies has given us the tools we're looking for, have helped to build a plan, and we've got confidence that we know where we're going and how to get there. And crucially, some of the concepts they used were think about boundaries that help flow. This is one of those concepts that's relatively new at scale in the industry, that Team Topologies has helped to kind of helped to focus the mind on this. So explicitly, we're thinking now about boundaries that help flow, whereas before they were thinking about boundaries around kind of technologies or boundaries around other things. But now we're thinking about boundaries for flow. So thanks to Richard for letting us share that. There's another example here from a UK government. I spent some time in 2018 as engineering lead. Most of 2018, in fact, I was an engineering lead at a program in the UK government Home Office. There's an interesting article online here, how the Home Office's Immigration Technology Department reduced its cloud cost by 40%. It's online, it's public. I worked alongside some of the people who were involved in this particular program of work. We were there every day, basically the same set of tables. I didn't work on this specific thing directly, but I was kind of involved peripherally. And there's some really cool stuff. They came up with this kind of EPC type chart for cloud costs. So, hey, if you use Spot instances in the cloud, you can reduce your cost like this. If you use a different type of database, you can reduce your costs as well, and so on and so on. Kind of cool stuff. But here's the thing. What I saw, which is, you won't read it in the article, what I saw is this. Making service owners accountable for the dollar spend for their service helps to clarify service boundaries. So by putting the responsibility for financial accountability effectively onto service owners, they're much more inclined to find good boundaries that work for flow. So cost metrics ends up like a financial scalpel to split services apart for fast flow. I actually had a chat with someone who's still involved in this work recently in the same department, and he said, "Yep, this is exactly what's continued to happen since 2018." So all very interesting. Let's have a look at how to detangle with metrics and team topologies. First thing, track dependencies and separate them as blocking versus non-blocking, because the dependency in itself is not a problem. We've always got dependencies and we always will have dependencies. But if the dependency is blocking, like shown at the top of the diagram here, then that's a problem for flow. We have to wait on another team until that's finished. What does it take to turn that blocking dependency into a non-blocking dependency that we can consume from what we call a platform? That's shown at the bottom of the diagram. That's the general principle, turn a blocking dependency into something non-blocking. We can use tools like CodeScene to detect hidden coupling. CodeScene is an amazing tool. I wish I'd written it. Here's a screenshot, excuse me, of part of the tool. And this particular part of the tool is like measure how well your organization aligns with your architecture. This is by just looking at version control repositories. It's picking out all kind of interesting information. Super, super handy tool. So go to codescene.com if you're interested in that kind of thing. You can use some team dependencies tracking tool that we've got on GitHub. This is Creative Commons, so kind of open source. It is inspired by some details from Spotify, but we've expanded it a bit using some team topologies ideas. So you can use these team dependencies tracking techniques to find and remove dependencies that hurt flow. And then finally, there's some newer tools coming out, things like Teamform, where it's using metrics and other kind of insights to give us new awareness about what's happening inside and between teams in relation to building things. It's really interesting, the number of tools in this kind of space. There's like team telemetry that's inspired by team topologies, explicitly has team topologies kind of metrics and principles and things embedded in it. Is really interesting. This is not the only one. There are many more as well. Okay, this is what we've looked at. So here's the clickbait summary. You too can save €8 million a year by decoupling for fast flow. The slightly less clickbait summary of this talk is this. We can use balanced health metrics like DORA, flow, cost, and blockers, and so on, combined with some team topologies techniques like independent service heuristics, using these mapping, team interaction modeling, to help find good boundaries for fast flow by untangling and decoupling separate services. That's the key takeaway. So I'm looking forward to some questions, like I'm interested in your perspective, interested in which things resonate with you, which things don't feel correct. Let's have a chat and see what we want to get to. So thank you, and let's have some discussion on this now.